All right, let's go ahead and get started here. Welcome, everybody. As a reminder, your homework assignment is due on Wednesday of next week. I'm not sure why that's not going full screen. Well, so the assignment is due on Wednesday of next week. If you have any questions on that as you're working on it, you can send me an email. You know, we've got a long weekend because Monday is a holiday. We won't have any class on Monday, so we're not going to see each other after this lecture until the assignment's due. So you can stop by my office if you'd like on Tuesday. I will be around. Or if you have any questions as they occur to you, you can send me an email and I'll do my best to respond. Before we start talking about cash flows, are there any questions about the stuff that we did in class on Wednesday? Yes?
Can I ask a question about the board? Would you like for us to write out the question before we answer it on our paper?
I don't have a strong preference either way, whether you write out the question statement. I think it's a good practice to be in. I think it's a good habit, but I won't insist on it. Yeah. Are there other questions? Okay. Well, let's talk about cash flow diagrams and what they're for and why we have them. First of all, consider this very simple problem statement. This is about as easy a problem statement as we could write when it comes to time value of money type problems. You borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? And so it's not really lengthy, but we can summarize this unknown and we can summarize the entire problem graphically in a more succinct way than that text can. And so we can do that using cash flow diagrams. And so let's talk a little bit about some of the standard expectations when you're doing a cash flow diagram. I can't take it. It's driving me nuts. I got to get rid of that. All right, what do they call that? The taskbar? How do I minimize? No, I don't want to lock it. I want to hide it. Let's try that. There it is. That might work. All right, I won't lose my mind now. All right, so the first thing that we do with these cash flow diagrams is we have to represent time. Time is a horizontal line when we're doing these diagrams, and we have to begin with indicating when is now. And from our perspective, we say that time zero is the present, or whatever the present is in the context of the problem statement. So even if the problem says in 5 years you're going to borrow money and then this whole project starts and like the beginning point is already known to be 5 years in the future, you may need to represent that future point when the entire project kicks off as time zero. It all depends on the context of the problem, but the main idea is that we represent time, the passage of time, with these hash marks each period. It's very common for the periods to be years, but there are other time periods. It can be quarterly, it can be monthly, and so don't always assume that 1, 2, 3, 4 is talking about years. It often is, but not always. As much as possible when you're sketching these sorts of things by hand, you kind of want to make the hash marks equally spaced apart. There's limitations on how accurate you can be when you're freehanding things. That's one of the reasons why I suggest that it's a nice idea to do the homework assignments on engineering paper rather than on lined notebook paper. Does anybody have a pad of engineering paper here today? A lot of you do. I see someone here. So for those of you who haven't ever used engineering paper before, this is what it looks like. It's blank on one side, and on the back side of the paper there's these graphs. And the reason why it's on the back is so that you can just faintly see it. But if you photocopy it or take a picture with cam scanner, these lines don't show up. So like an actual normal graph paper is kind of really a nuisance to look at because all of the lines kind of obscure your writing. But the lines are just faint enough that you can see them. And these are great for cash flow diagrams because now you can draw to scale a little bit more easily. So I really love it if you do your assignment on engineering paper, although it's more expensive than it ought to be. And they charge a lot for engineering paper. And so another approach is just to use normal copy paper, but then to put a piece of graph paper behind it. And then that way you still have like the guidelines there faintly, and maybe it's a little bit cheaper per page. We engineers are always looking for efficiency, right? All right, so this is the passage of time. So above the line, we're going to be drawing arrows that represent the money that come to you, and below the line, it represents the money that's going out from you, assuming that you're summarizing your perspective. And remember, on the very first class day, we talked about the difference between rate of return and interest rate. The formulas are the same, but whether we use one phrase or the other depends on whose perspective we're considering things from. So in the same way that we have that, where we consider the perspectives, here we have to consider in the problem statement, whose perspective are we sketching? Are we sketching our perspective or the bank's? Because from our perspective, if we borrow $10,000, then that means in year 0, we're getting some money coming to us. And so we would draw that above the line. So from our perspective, you can see that in year 0, which is the present, we've taken out a known amount of $10,000. The fact that it's a known amount is indicated by the fact that that arrow is solid. It's not a dashed line. You can notice that on year 5, we have a dashed line, and that dash is one of the ways that we can summarize that that's an unknown amount. The other, of course, is these question marks here. That's the other way of us saying this is some unknown amount. But now consider the text versus the sketch. The text you can read, and everybody here is capable of figuring it out. But this, in about half a second, once you get used to reading cash flow diagrams, in about a half a second you can see and instantly understand what kind of problem this is and start to think of how you're going to solve it. So this is just an efficient way to illustrate problems, and especially when they get more complicated. When there's random amounts in various years and there's a lot of moving parts, just the sketch is a nice way to summarize in one place everything that's happening. Whereas a lengthy paragraph of text, you may forget about some aspect of it. The cash flow diagram is just a way to tie it all together in one spot. Okay, one last thing I'll mention is that it's customary to also, somewhere on the sketch, either above or below this horizontal timeline, you also say what's the interest rate. In our case, 6%. Okay, so does this make sense to everybody? Just the idea of visually summarizing the problem statement, the given, the unknown? Any questions about this? So as you might expect, the in-class exercise we're going to work on today is a chance for you to practice this new idea of summarizing problem statements with cash flow diagrams and also interpreting them. A couple other points that I'd like to make. First of all, time can be a little bit confusing for people because the end of year 1 is right here where the line is that says 1. So this is the first year. The first year starts at 0 and goes to the number 1. So that, this maybe seems really obvious, but at some point in the semester, probably everybody here is going to have to stop and think, all right, is this the beginning of the year? How much time has passed? You can sometimes need to prove it to yourself that 1 year is from the beginning of this increment, which is the end of the previous year. So take, for instance, from in the second year. The second year is from the end of the first, and so from line 1 to the end of the second year, which is going to be the beginning of the third year. So the customary assumption when we do cash flow diagrams is you assume end of period cash flows. So the end of period cash flow assumption is a little bit like this. If you're operating a business and you're trying to summarize your revenue and your costs on a cash flow diagram, the way to do that is you take all of your revenue and all of your expenses and then you combine them together and represent all of them at the end of the period that they apply to. So if you're doing a month-by-month summary and you're doing a cash flow diagram, then you'd have at the end of this month would be where you'd put the arrow that's associated with the revenue or the costs. So the end of period assumption, you'll get some practice with that, but that's one of the default ways that we handle problems like this is rather than representing at the beginning of the period, it's at the end of the period because, you know, it's the most realistic of the assumptions is that you'll be paid after you do the work. Or when you get a bill, you have some time until you need to pay the bill. Things happen at the end of the periods that they're related to. The other thing that I want to point out is that the scaling, the arrow heights should be, if not scaled precisely, at least larger and smaller. You know, if one of them is meant to be a greater amount, make the arrow larger than the adjacent arrows. It's easier to do scale on the engineering paper, but at the very least you should just make some effort to make the relative size and the relative amount of things clear from the size of the arrows. Now just because a cash flow diagram has a certain number of hash marks on it, the number of hash marks does not imply when you should end the cash flow diagram. So here you can see that we're taking this amount to year 5. We're trying to find out what's the equivalent repayment that's going to be required. You know, if you take a loan of $10,000, how much do you have to pay back in year 5? Well, there happened to be on the cash flow diagram a year 6. And sometimes people can get hung up on like how many marks there are on the cash flow diagram to assume that that's when they're supposed to take the unknown amount to. So if I hadn't, just as an example, if I hadn't put that arrow on there, my past experience says that some people would just assume you're trying to figure out how much is the loan amount in year 6 because that's the end of the cash flow diagram. But really, that's not the end of the cash flow diagram. Time continues indefinitely, we hope. So you basically just have to read the problem statement and take the time to take the amount to the years that are indicated. All right, so these are the labels and the symbology that we use. We've already talked about how interest rate is represented either above or below the cash flow diagram. N is the variable that we assign to the number of periods, whether they be years, months, quarters, whatever the case may be. P means the amount at time 0, and we call that the present, even if it's some future date. It's kind of like the beginning of the project is what's the present from that perspective. F is the amount of money in the future. So in that previous example, P was 10,000, I was 6%, N was 5 years, and F was the unknown. Now it's okay on these sketches to represent it either as a percentage or as a decimal, but you wouldn't just want to say I equals 6. You'd either need to say I equals 6% or I equals 0.06 because you're going to be putting these numbers into equations and you don't want to have the bad habit of expressing the interest rate as a whole number when really it's a fraction or a decimal. There are problem types that you'll become acquainted with through the semester, and the problem types are often summarized as what you're trying to find. And so sometimes these problems are called present worth problems. And all that means is you're taking some amounts in the future and you're trying to find out how much is it worth today. what is the present worth of these future revenues or future costs. So it's essentially converting, because of the time value of money, converting things into the perspective of the value of money now. So if I said I'd pay you $1,000 in 5 years, how much is that worth today? $1,000 in 5 years. Remember, we've already agreed that money in the future is less valuable because prices are going up, so you can't buy as much stuff with the same amount of dollars in the future as you can now. So if I give you $1,000 in 5 years, the question is, how much of a trade would you be willing to make to have it today instead of waiting in 5 years? Would you take $850 now rather than $1,000 in 5 years? So discounting the future amount to the present is what these present worth problems are all about. Okay? There are also future worth problems where the unknown is some future amount. They're sometimes called future value problems. You're essentially finding out over time how much do the amounts compound. Now, in this previous one, when we were talking about present worth, there was the word discounted cash flow. And the reason why that word discounted is in there is because when you're moving future money backwards in time to the present, the amounts are getting smaller. And so that's a discount. Remember, the idea of $1,000 in 5 years isn't worth as much as that today. And so you'd be taking a discount. So the opposite of discounting is compounding into the future. Finally, we have problem types where we're trying to find a uniform annual amount. And so a uniform series or an annual series are consecutive payments, consecutive meaning that there's no gaps. They happen year after year with no interruptions, and the amounts are equal. And of course, the end of period assumption also applies for annual worth problems. So these are the 3 problem types that we'll be solving over the next couple of class meetings to account for the time value of money. There's lots of ways to do it. There are formulas that allow you to calculate this. You may have noticed at the back of your book are these just page after page of interest rate tables. And those interest rate tables are the equations that have been solved for a certain number of years. And so you don't always necessarily have to crunch all the numbers and do all the calculations with the formula yourself. Sometimes there's like a streamlined approach that I'm going to show you how to use. Okay, now you've seen all these definitions before except for those annual worth problems. We just abbreviate that with the letter A. If it's on a cash flow diagram, we'd call that A. Are there any questions so far? Okay, inflow can be the revenues you receive for operating a business, receipts, income. These have a lot of different names. One of the things that is a little bit of a surprise the first time you learn about it, though, is that a cash inflow could also be when you're saving money that you used to spend. So say, for instance, that you have a really inefficient furnace at your house, and right now you're spending $300 a month on fuel oil. If you replace that with a more efficient heat pump, and now your energy costs are only $50 per month, then the savings between what you used to spend and what you have to spend now, the $250 difference between $350, those savings can be considered as a cash inflow. So it's not actually that someone's giving you the money, but compared to the status quo, compared to the baseline condition, you are getting an inflow. Does that make sense to everybody? Savings from a project? Okay, outflows are also known as disbursements or costs, expenses. Those are all interchangeable. They can also be related to the taxes that you incur when you're generating revenue. And we use a minus sign when we're calculating the net cash flow. Net cash flow is the difference between the two. It's the inflows minus the outflows. and hopefully the net cash flow is positive, or else you've got a problem. Revenue minus disbursements is how it's summarized in the text. And remember, the end of period assumption means that we just combine all of our inflows and outflows during a period, and we represent as a single combined amount at the end of that period. You have to be kind of careful, though, because sometimes I'll give you a problem where I tell you a monthly revenue and a monthly expense, and you'll be tempted to just add it all up and express it as one single amount at the end of the year. But if I had given you the interest rate on a monthly basis, then that would be a hint that we're solving this problem with periods being months rather than periods being years. And so my point is, don't aggregate amounts too much. Don't always combine things into years if our periods are months. Okay. Most of the time, when you're solving a problem or when you're drawing a cash flow diagram, you will represent these future amounts as point estimates. And so this is an illustration of how we just assume that we're able to predict with certainty how much our revenues will be in the future. And so this cash flow diagram is saying that each year you have an annual revenue of $150,000. Now, there are certain things that you can predict with absolute guarantee that it's going to be that way, and sometimes there's a lot more risk that the amount could be lower or maybe higher than you expect. And that is when we instead express these cash flow diagrams with a range estimate rather than a point estimate. And so if you want to illustrate the maximum and minimum expected values, what you can instead have is like a range bar. And you maybe have seen error bars before. This is just a bar that shows the expected low and high possibility. And so the purpose of having a range estimate like this is just to kind of consider all the possible cases that could occur. In the end, this course is a lot about decision making and trying to pick which project is better or whether a certain alternative is acceptable. Whether you're considering a new server or you're trying to evaluate a piece of equipment that's used in manufacturing. You're going to be spending a lot of money now with the hopes of you can recoup some investment in the future. And you're always maybe tempted to simplify things and say, well, I know it's going to generate a certain amount of revenue 6 years into the future, but it's always better to consider the entire envelope of possibilities. Run the numbers with the worst case scenario of that $135,000 per month and see, is the equipment justified at the low end of the range? And then you perform the same estimate to see what would be the present value of this cash flow if it was $150,000. So just kind of approximating the uncertainty is the idea of a range estimate. Okay, I'm going to hand out InClass Exercise Part 1. What I'd like you to work on is just the front page of this, just a chance for you to sketch some cash flow diagrams. Okay, let's take a quick look at number 1 and see if we're all doing the same thing here. So the problem statement is today you receive $10,000 from the bank, and then starting 1 year from today you make 4 annual payments to the bank in the amount of $3,300. Okay, so you get money today, and today is year 0, and we don't have any information about whose perspective it is, and so we assume that it's our perspective, that we're drawing this not from the bank's point of view, but from ours. So that means that time 0, when we get this money, is a line that's upward, and then you can see that there are 4 downward arrows in the amount of 3,300, and that's an annual series, so that's an A. Any questions about this first one? All right. It can help if you use a straight edge on these. I used a ruler, and just to make sure that the lines are equally spaced. You can see I didn't use an arrow or a ruler on the arrows, though. They're a little bit wavy. It's all right. You get the main idea. Okay, let's look at problem 2. Now, this one could be a trick question if you don't catch that it says, draw a cash flow diagram from the bank perspective. So I started off by drawing it from my perspective, and then the bank's perspective is going to be the inverse of that, or the mirror image. So you will save $10,000 at the end of each year. That means you're making a deposit. And I know the word save can be confusing because I've just a few minutes ago talked about if you're saving money because you got a more efficient furnace. This isn't that kind of save. This kind of save is you're making a deposit in the bank. So that's an outflow. Okay, so from your perspective, you're doing an outflow at the end of each year for 6 years. And then in the 7th year, at the end of the 7th year, so here's the first, here's the second, here's the third, and so on. At the end of the 7th year, you withdraw the balance, and the amount is not known. So the dashed line there means it's some unknown amount that we haven't calculated, and we can't calculate because we don't have an interest rate. So that's our perspective, but the bank views it the opposite. The bank views it that, there we go. The bank sees that they have money coming to them at the end of each year, 10,000 at the end of each year, and then at the end of the 7th year, they're going to have some withdrawal. All right, so any questions about that one? All right. Maybe some of you have already flipped over to the back side of the paper. Let's talk about that one. Let's talk about how we sometimes will translate a cash flow diagram into a cash flow table. Excuse me. It's kind of self-explanatory. The only one thing I want to highlight is that sometimes in a given year there will be both an inflow and an outflow. And it's really important that you calculate the net difference between the two. We're going to be doing some procedures later on in the semester where you calculate the interest rate, like where the interest rate is unknown. You'll have a cash flow diagram like this, and it'll say, find the interest rate that makes the inflows and the outflows in equilibrium. And if you don't calculate this third column in problems like that, if you don't find the net, then your answer will be slightly off. So this is just kind of some first practice to translate the cash flow diagram into a table. So now we have 3 different ways that we can summarize problems like these. First, just the text. Second is graphically. And then third, we can summarize these problems tabular, so in a table. So let me give you a moment to write all that in.
Factor in the interest for the present amount?
Good question. The present amount is unknown, and so you just leave that row blank. So we're not actually solving for how much that amount is. You're just translating the cash flow diagram into the table. So the first row will be blank. But this is one that we could solve since we have the interest rate. Okay, the solution to question 3 is up on the screen there. I almost fell into my own trap. That first row represents the present, and we don't have any amount already in the present, and so we can't write any inflow amount or outflow amount. Now, although the interest rate of 8.5% is known, each row is just asking how much is the amount in that year. We're not yet trying to find what's the present value of a certain amount. We just want to find out how much is it in the year that it's received or dispersed. So for instance, this year 2, the $2,000 in year 2, that is a $2,000 inflow amount. Now, in the present, it's not worth $2,000 to us, but in year 2, that was the amount, and so that's why we put it in the table. So you can see that we have inflows every year, outflows on 2 of the years, and then the net cash flow is the difference between the inflow and the outflow. So NCF is in minus out. So it's 2,000, 2,000, and in year 3, it's only 500 because that's the net difference between the inflows and the outflows. Mm-hmm.
Earlier in the slides, I thought we explicitly stated that F was an amount of money that I had in the future, and that any deposit would be represented with, or any money taken out would be represented with a negative number. And if I had 1,500 F, wouldn't that mean I only lost 5? Or is it just an unfortunate choice of letters used? Because F is future money, right?
It means a future amount.
So I have 1,500 in the future.
This 1,500 means that since it's a downward arrow, that's an outflow, right? So it's not that you have it, it's how much you have to pay. All right, so I've got the solution to 4 and 5 up on the screen there. From the bank's perspective, when you receive $25,000 from them, you're getting money, which is an inflow to you, but that's an outflow for them. So they have that downward arrow in the present. So P equals 25,000 in the present, and then in the future, you're going to repay them. So their inflow comes in year 3, and F equals 30,000 for that one. Now, I got a good question I was walking around, and that is, is that an annual series or is it a single amount? And so in this case, it's a single $30,000 payment that you're going to do in year 3. So some of the clues, if it had said each, then that would be an indicator that it's an annual series, or if it said every year. But otherwise, this is just a single payment. All right, problem 5 I threw out there just kind of as an early taste of what we're going to be getting into next week. I wanted to see how many people would this already make sense for. And if it doesn't make sense for you yet, that's okay, because I'm giving it to you a little bit early. But the idea here on problem 5 is we have some formula that says what is the future amount for a certain present value as a function of the interest rate and the number of years. So we have 2 single inflows that's coming to us that we have to pay back in year 5. And so this $10,000, if you think of it as a loan, the $10,000, we're going to have to pay back interest that accumulates over the course of 1, 2, 3, 4, 5 years. And so 10,000 times 1.06 to the 5 power, because that 10,000 that we get in year 0 is going to be accumulating interest for 5 periods. But the 5,000 that we receive in year 1, that only accumulates interest over 4 periods. And so we have a separate row where we're saying the $5,000 is compounded for 4 years, and so the combined amount is $19,694. So we'll be doing a lot more problems like this in the future, and I'll sometimes start to talk about moving the money. And I mean that in a graphical sense. Like this amount that's in year 0, to find out how much it's equivalent to in year 5, you have to move it 5 years. and the amount that's in year 1, you're going to be moving that 4 years to find out its equivalent value in year 5. All right, so that's a preview of things to come. Let's take one last look at these announcements here. Your homework assignment is due on Wednesday by noon. So I hope you have a good long weekend, and I'll see you on Wednesday.